Hi, welcome to Teardown Tuesday. Today we're going to take a look at one of these omnidirectional barcode scanners that you've no doubt seen and used at your local supermarket checkout or something like that, where you just wave the product in front of it and it scans the barcode at almost any angle. So you can probably see sort of stuff rotating in there and puts like a laser pattern, and it can read the barcode in any direction. So what's inside one of these things? Well, let's find out. Now, this is a Symbol brand one. They used to be real top-notch, but they got bought out or acquired by Motorola or something like that. So this one is still available. This model is the LS9208, but it's available as still the 9208, but under the Motorola brand. So I'm not sure if it's exactly the same. So although it's 1996 vintage, it was pretty much state-of-the-art at its time in terms of omnidirectional barcode scanners. So it should be fairly representative of the technology. Now, you're probably familiar with these USB line scanner ones. You can pick these up on eBay for like 20 bucks or something. They're super duper cheap, and basically by line scanner, it's pretty much, you can see the laser there, it just does a single line. So if you go like that, boom, it just reads sort of these one-dimensional or line-based barcodes. But these ones are omnidirectional. Let's take a look at the pattern in this one. Now, it's actually quite hard to get the pattern of this one on camera because it's not very bright at all, but you can see that it pretty much has multiple scanning lines. It's still a line-based system, so to speak, but it has multiple lines in all these different axes like this going. So one's going down like that, one's going down like that, and then scanning across like that, and then one's scanning up and down like that, and across in all those different angles, so it can pick up the barcode in pretty much any orientation. So no matter how you wipe the product in front of the scanner, it's going to pick it up. So with your traditional line scanner like this, you have to bring it down and then over the code like that. If you bring it down, of course, in that direction, it's just not going to read it at all because it can't read the pattern. But with these omnidirectional ones, you can read them in pretty much any orientation. You can bring it down, whoop, bring it in like that, bring it down like that, even on a really small angle like that. That is a ridiculously shallow angle, and it's still reading that. No, there's no barcode on the back there. It's actually reading that, and you can come in at an angle like that and it gets it. So you can just pretty much just wipe the thing in front of it, and you're used to doing that at your checkout, and it's that omnidirectional scanned line pattern that makes it do that. And similar to these USB based ones, which just basically simulate a USB keyboard. So it's just like you type in these symbols in. Your software doesn't know any difference. You don't need any fancy drivers or something like that. This one is what's called a keyboard wedge device, i.e. it wedges in between or in series with your, in this case, an old style PS2 keyboard. And of course, here's the power coming in from the external power plug pack for this thing, and it just simulates the key presses, so it basically can work with any software or any point of sale system. But on top of this keyboard wedge option, you can also get a USB option as well, and a serial RS-232 and some sort of custom IBM protocol interface. And I believe all the hardware is built in here. You just require a different cable. Look, it's got like an RJ45 plug on here, but I only have the cable supplied for the keyboard wedge here. But you can actually scan in different barcodes. This is what they give you in the manual here, and you can actually configure the device after you powered it up by actually scanning the particular barcode you need and setting it up that way. It's quite a clever way to do it. So I can configure all sorts of stuff like this from the manual by just scanning in the particular type. So it's going to be interesting to take a look inside this thing, and we're obviously going to have motors and mirrors spinning around and all sorts of jazz to make those multiple lines. So according to the specs, it's got 5 different scan angles and 4 lines per scan angle at a 4 Hertz raster rate. So it can scan those at 4 times per second in those angles. So let's take a look at it. All right, let's crack this thing open. There were just 2 screws down in there, and presumably, yeah, it's just going to pop. Whoop, something's fallen out. That's the RJ45 jack connected via a little flat flex ribbon, but there we go. We're in like Flynn. Look at that. Straight in, and doesn't that look gorgeous? That looks like a gold reflective mirror in there. Oh, beautiful. Now, without even powering it up and seeing it in operation, it's fairly obvious how this works here. Here's our laser diode here mounted in this big die-cast alloy bracket here. Probably got some heat sinking happening on there. I'm not sure of the output power of the laser diode. What is it, 1 milliwatt or something like that? And the manual says this is a class 1 laser diode, which is what you'd expect. It means it's basically safe in all modes of operation pretty much, which it would have to be, you know, being at a consumer checkout point here. But basically they've got the laser diode mounted in here, and it's a long way reflected off this. Look, you can see it shooting out there like that, reflecting off that inner spot right in there, and then that just bounces around, then that bounces off this mirror down in here like this, and then it bounces off the 5 different segments that we've got. 1, 2, 3, 4, 5. So there's our 5 different segments. So if our laser diode here is fixed, it's shock mounted. Check it out. It's actually the whole arrangement is shock mounted, so you know, when you throw products down on the bench or something like, you know, on the countertop, the vibration doesn't come through to the scanning optics in there, which, you know, is a big deal when you're using it in a consumer point of view. You know, vibrations can easily go through this bench. If I sort of throw something down on this bench next to it, all that vibration and shock is going to come through into the electronics. So they've got those nicely decoupled in there by way of these shock mounts there, and there, the entire system. So we've got ourselves a fixed laser diode module here. Screw adjust there, so they can tweak the angle on this thing after they've actually produced it. And then all of our scanning is done by this mirror down in there, and you can, yeah, I can move that by hand. Oh, look at that. It's a prism. Look at that. That's terrific. Wow, look at the sharp point on that. So obviously it's all in the timing, of course. So the optic output from the sensor would have to, is timed with the mirror like this to actually get the reflected image back in there from each particular angle, and then it's scanning that. So we can actually power that up and watch this thing spin around. That'll be terrific. Woohoo! Love it. So they don't really have anything fancy. That's a neat way to get all of these different scanning modes. As you can see, 5 different angles with 5 lines per mode on this thing. So it really is rather amazing. And there's our photodiode sensor down in there, and it's got a shroud on top. We can probably, yeah, we can peel that off. There's no part number or anything like that in there, but there you go. And there's nothing fancy going on there at all, but you can see that there is some extra filtering going on in that thing. Here we go. I'm going to power it up, and well, there we go. There we go. Our mirror's scanning down in there, and yeah, you can see some of the yeah, you can see the laser shining off there like that. Beautiful. This mirror up here, I can, if I put my finger on that, I can actually feel that. I'll get in there with my macro lens and see if you can see that move. And there you go. Hopefully you can see that mirror. Bit of shimmy in that mirror. If I turn it off, there we go, and I'll apply power. And it's starting up. There it goes. Just the tiniest little amount of wobble in that mirror. So I'm not sure how they're coupling that through. There doesn't seem to be a motor there. They might be getting some sort of vibration through from the other one in some sort of clever way. So I'll show you what happens with the scanning pattern if I actually stop this mirror up here with my finger from vibrating. So let me see if I can get that pattern. So that's normal, and let me put my finger on the top of that. Here we go. You can see I can physically stop that from scanning across in that direction like that. So you can see the spec is correct, right? We've got 5 different angles there with 4 lines per angle, and it's a scan at a rate of 4 times per second, and that's about what it looks like. So, yep, spec confirmed. And that prism down in there, it's got 4 sides on it, but they're not identical. They're all angled slightly differently, even though you probably can't see it, and that's how you get your 4 different scan lines that you get in the spec. So, you know, they might have a lesser model that might only have 3 scan lines, for example. Well, that one won't be a square, it'll be a triangle. And I'd love to be able to show you how the angled mirror in there, the rotating prism, the 4-sided angled plates actually give you different scan lines, but unfortunately if I stop that motor, then it actually just switches off the laser, so it obviously senses that there's an issue and switches it off. So unfortunately, unless I bypass it, jury rig it somehow, then nah, it's not going to work. And I can show you that by sort of slowing it down a bit. Here we go, maybe. Let's have a look. Whoop, there we go. I just switched the laser off. Switched it back on. There we go. Nah. But it's certainly fun to just apply your finger on the top vibrating mirror there, and I can just get and I can just scan that manually, slowly like that. That's rather neat. But those 4 lines there, 1, 2, 3, 4, are determined by the 4 different angled surfaces on that rotating prism. Now, what I'm going to do is I'm going to test if this laser diode here actually has any functionality as part of the scanning process. So here we go. I've got my barcode on here, and I'm just going to scan that in. There we go. Okay, no problem whatsoever. And I'm going to block off my laser diode with my pointer here, and look at that. No, it clearly can't read that barcode, and no matter how many times I do that, I cannot get it to even beep or scan that thing once. So obviously the laser diode is a very critical part of the illumination mechanism for illuminating the barcode so that this thing can pick it up. And probably no wonder, I mean, I'm a little bit surprised by that actually. I thought you know, it may have actually still been able to read the barcode using ambient light or something, but clearly what's happening is that the laser is scanning across the barcode like that, and then they're filtering that and with the lens on the front, and they're getting the difference between the dark, i.e. it's going to reflect off the white surface and it's not going to reflect off the dark surface. So that's how they can get the 1s and the 0s and identify the barcode on that particular thing. So there you go, that laser diode and the vibrating and the scanning and all the different angles, that's a critical part of the illumination of this barcode. It simply does not work without it. Doesn't work with just ambient light. So that sensor in there, I mean, you probably could tweak it to get it to work under ambient light conditions, but it's obviously much more reliable to get the contrast required by lighting it up with a laser diode like that. Okay, let's try that again, but in dark. It's not completely dark here in the lab. You can see the grain on the camera image. It's really gained up on my camera, but it is pretty dark in here. So, let's, yep, no problem whatsoever. There you go. And if I make it even darker, I'm putting my jumper over the top of this whole thing, so it is pretty pitch black in there, and no problem whatsoever. So that illumination system works fantastic. And likewise in bright conditions, give it a test. Here we go. I'm going to shine my torch onto this thing so I'm really overexposing that. And yep, you can still read that even under really bright light conditions. Alright, what I really want to see is how they're vibrating this top mirror up here. So let's try and get this whole, hey, I think, yeah, look at that. Just comes out as one big thing. We've got some soft padding in the back there, and aha, there you go, electromechanical vibrator in there, and that's just transferring that through to the top there. There we go. That's what I couldn't see before. There was that bar. Well, I could kind of see a bar going down, but I thought it might have been maybe tied to the other motor or something. But no, there you go. It's got its own little vibration coil there, and a couple of more little shock mount things there, and that's about all she wrote. And there's a little DC motor in there, and yeah, that's not just, they're not just ramping that up, they're controlling the speed and getting probably getting the time in from that thing as well. And this flap they've got on here, this is obviously just to stop ambient light coming in, swapping the sensor from the front there, so you really only want the image reflected off that mirror at the back. And we haven't got a huge amount of chips here on our board, but let's go in there and take a look at what we have. Bam, bam! Bedrock 2 chipset, presumably Pebbles. There you go. So they're a fan of the Flintstones. So I don't know. We'd have to look up a number on that, but could be one of the custom devices for, particularly for decoding the sensor and getting the barcodes out. Obviously doing some sort of heavy custom processing there. And no, unfortunately, I can't find any info on that at all at a first glance. All I get is like a whole bunch of broker websites which may possibly have it, but no data sheet or any info like that. So if you do have any info, please leave it in the comments. Aha, main processor down in there, Hitachi H8S, old school. And likewise, that one, STI branded again, but it doesn't bring up anything at all. Can't find anything on the search there. So I don't know. Not a huge amount of I/O on that thing. A lot of power and decoupling there. I don't know. Is it some sort of serializer or something like that? I don't know. I'm just completely guessing. No idea. But obviously designed to match this STI chip over here. And nothing special down in there. We just got a 74 series 240 logic from TI. Well, there's our crystal oscillator. Another one under here that has a firmware label on it, so presumably a programmable device. Let's take a look at that one too. Aha, look at that. We've got ourselves an old Atmel AT91FR4042. That's an ARM7 thumb processor. That was pretty decent and grunty, back in the day, 1996, when this thing was done. So there we go. It was manufactured the 53rd week 05 there. So there you go. That's obviously doing the heavy lifting. So sort of like the image processing and stuff like that. So maybe this chipset, this custom, Flintstones chipset in here is, probably just doing some sort of decoding or something like that, but probably a lot of the decoding in real time done inside that Atmel ARM processor. It makes sense because you've got to do a lot of processing here, especially like the 5 different angles all in real time, 4 times per second, scanning that image. So this could be some sort of like a contrast image recognition, which like converts it into a more usable form, like a filtered form that the Atmel processor can then process in real time and try and get a barcode out of it, because you can program in, like, it's not just searching for one barcode, as well as all the different types. You can actually program this with the software. You can hook it up to a PC. It comes with software and tell it to read 50 different types of barcodes. So if you enable all of them to be scanned, then this thing has got to do a lot of work. I mean, I don't envy that thing having to process all the different angles and do all that and search for all the different types of barcodes. It's crazy. So no wonder they had to put an ARM processor in this thing. This one over here, of course, the Hitachi H8S, that's just, they're probably just doing some interfacing, all that protocol stuff, the US, because this has presumably a USB interface. So it'd just be doing like the interface work pretty much with the RJ45 here, because you don't want to do that in your ARM processor here. Just offload all that interface and protocol stuff over to here, but image processing there and protocol. So that's nicely segregated. I don't mind that at all. And on the back of the board here, there's a fair bit of passive work going on, but no sort of heavy-duty processing at all. But this is interesting how they've added this flat flex copper shield over here and soldered that on to part of the tabs. So they obviously needed some extra shielding on that. So that's clearly some sort of afterthought there, I think. Maybe it didn't pass EMC compliance, and whoops, let's just whack that across there. There's not a huge amount happening here. There's a classic LM358 op amp, and we've got some 7.4 series logic, HC4066 there. Absolute classic. And what's that little puppy? That 8-pin SO package next to it. But that there's all part of the laser drive circuitry there, because there's the laser connector on it, and this is all motor drive stuff over here. Here it is. So this is all motor stuff around here, and that's about all she wrote, really. Now that right there is a fascinating package. Look at that. Can anyone tell me what that is? Look at that. Some sort of optocoupler perhaps, with a split going right through it. That is very... and then potted, like, you know, two different halves potted. That is a fascinating package. Anyone? Now, look at that. I do believe there's another filter on the entry, and that doesn't surprise me at all, really, because you've got to get that contrast. You have to get that contrast with the laser diode against the bright and the dark patches on the barcode. But you can see how this is clearly like an afterthought. I mean, they've even put the product barcode on the bottom here, and then they've just tacked this on to, you know, to put a bit more shield in, or maybe they forgot the ground between there and there or something like that, and they're joining them together, and that was a way to do it. But there we go. We can get a real good look at that rotating mirror in there, the rotating prism, and it looks to be a slight curvature, or is that my imagination? No, that could be an optical illusion that there's a slight curvature on that thing. I think it is actually a flat surface, and that is really jazzy. I like that. Woohoo! Sex on a stick. And there's the prism in there, and you can probably just see how that some sides are angled slightly different than the other. Like that one is greater than that one there. A bit hard to see, but yeah, there's just a mild angle difference in those. And you'll notice that the top of the prism here has this reflective. There it is, it's reflective. We can see ourselves in there. Hello, there I am. And so it's got this reflective square with something in the corner here. I don't know if it doesn't appear to be a magnet or anything like that, but clearly they're doing this, and the rest of it is matte black. So obviously they're getting some sort of optical thing happening there. They need that surface reflective so that they can get the positional rotation of this thing. So that's got to be what this mysterious device is doing here. It's obviously detecting the positional, because this is the bottom side of the board, so it's detecting the rotational position of that mirror on there as it goes around. So how it's exactly doing that, not 100% sure. But my best guess would be that that is maybe a UV LED there, and then reflecting off into a photo diode here, so that when the reflective surface comes around, boom, it bounces off and it knows the position of, or at least the start position of that mirror, and then you can calibrate that in software, of course. So that's probably what's going on there. So I'd love to get a little data sheet for that thing, but that seems like the most obvious thing that's happening. And if we probe our motor here, this is our for that prism. There we go. We're getting about 147 hertz or thereabouts. Little bit of jitter on that. You can see, as you'd expect. In fact, I can probably get the histogram data up on that. There we go. We're getting a standard deviation there of 600 millihertz or thereabouts. So there you go. That's the clock driving the rotating prism. And that's the drive signal for that top coil on the top mirror that vibrates, that has that vibrating shaft going up to it. And that's about 33.7 hertz or thereabouts. So there you go. I hope you found that teardown interesting of this omnidirectional scanner. And unfortunately we can't go a huge amount further, I don't think, without any data on that Flintstones chipset, exactly what it's doing in there. So if anyone's got any data on these things, then please leave it in the comments. But there you go. That's how one of these omnidirectional barcode scanners work, and they're quite neat. There's a whole bunch of you know, laser and optics and mirror optics and stuff going on there, and lots of data processing and filtering and things like that to give a rather clever solution to scanning those barcodes in pretty much any orientation. I love it. Woohoo! Vibrate. Ooh, I could play with this all day long. Catch you next time.